Dear students, today we are going to discuss the formula which we shall be deriving in the few lectures followed by this lecture. But for the time being, we are just mentioning all those expressions all together so that we have a better view of the whole thing. Here we are talking about a new expression for refractive index in terms of, again we are using the same prism formula, but we are here assuming that the angle of incidence and hence the angle of refraction both are very small, and for that case we have always a sine of the angle nearly equal to the sine itself. That means sine I say will be taken nearly equal to I itself, and therefore if you write mu21 is equal to sine A plus delta m by 2 divided by sine A by 2, that can be written as A plus delta m by 2 divided by A by 2. So here we are making the assumption that the angle of incidence and angle of refraction both are very small, and therefore it finally becomes A plus delta m by A. What is delta m? We must be knowing it, that it is angle of minimum deviation, and so we have 1 plus delta m by A, and that can be further rearranged to write the value of angle of minimum deviation in terms of refractive index and the prism angle A. Now we talk about yet another expression for the refractive index in terms of absolute refractive index of the mediums. Say we are taking the first medium as air, and say for example the second medium as glass, and in that case we are also taking the convex surface of the refraction taking place at the convex surface of the lens. That means if we take an object on this side and then the image of this is formed somewhere over here, say for example image is formed over here in the second medium and the surface is convex, spherical refraction is taking place at the spherical surface, then for that situation we derive this expression which we shall be actually deriving in the coming lectures in this same chapter. Now, where mu1 is the absolute refractive index of the first medium, this is the first medium and this is the second medium, and mu2 is the absolute refractive index of second medium, and r is the radius of curvature, means whatever is the radius of this spherical surface whose part is this spherical surface at which the refraction is taking place, that is the radius of curvature of the spherical surface. I believe that even if you don't have a better understanding of these terms, we shall be learning it when we actually derive these relations. So now yet another relation, these two, the next relation is actually applied in the experiments, but we do also have situations when we get numericals based on these expression. So we are also including it in this form of refractive index is a refractive index of second medium with respect to first medium, refractive index of a denser medium with respect to a rarer medium is given by 2 minus fg upon f, and that is also equal to f upon f1. What is fg? Fg is twice the focal length of the convex lens, and capital F is twice the focal length of the combination of water lens and convex lens. What we are doing in this experiment is we we take the lens alone and find the image of an object formed at its center of curvature, and then we place some water on the mirror upon which the lens is placed, and then again find the center of curvature of this for this combination of water lens and convex glass lens. This is glass lens, which is a convex lens, and here water lens is formed, which is plano-concave lens, because you see this is the shape of the lens and we are placing water. So what happens, the water is forming a plano-concave lens. Plano-concave lens. This is filled with water, so this acts as the plano-concave lens, and the focal length of the combination of these two lenses, water lens and convex lens, glass lens, is found to be equal to 2 minus Fg upon F, and since the Fg is nothing but 2F and capital F is nothing but 2F1, so we get 2 is cancelled, so we get 2 minus F upon F1. Now this derivation we shall be talking. There is yet one more relation regarding the refractive index, which again we find in its application in experiments. So we shall be talking about it whenever we talk about the numericals based on this theory. So that's all for today. Thank you and have a nice day.